Four scholars completed their PhD degree under Dr. Ghorai. Currently, three research scholars are working under him. Currently, he is an associate editor of journal Complex and Intelligent System India, Frontiers in Artificial Intelligence. Okay. Okay, now Dr. Ghorai, the is yours. Microphone. অ্যাডোব নেই এখানে দেখছি good afternoon, everyone. So, so just we have heard about the polygraph theory, and we know that we have already crossed 50 years after the invention of polygraph theory. So, you can imagine that there is so much work having done in this field. So, actually, my talk will be focused only in the current research areas that we are working last 3 to 4 years. I'm not going to cover the all works. So, and my talk will be beneficial who are already working in polygraph theory or those who want to work in polygraph theory. So, I'm not going to the basic definitions of results in polygraph theory. Our Sal has nicely represented the basics of polygraph theory. So mainly I will focus the recent developments that we have made or other researchers have done. And lastly, I will also talk about the future research direction that one can work. Okay, so first of all, I will talk about the polygraphs and the topological indexes in polygraph. So actually, topological indexes is a very most important tool in chemical graph theory. But nowadays, with the researchers in polygraph theory, we have uh, developed or defined those indexes in polygraph theory. So, so what is topological index actually? What do you mean by topological index? Topological index actually is a numerical quantity that satisfies that it remains invariant under any particular isomorphism, and it doesn't depend on vertex level also. And in chemical graph theory, Wiener index, which is also known as Wiener number, and this was first introduced by Harry Wiener, and it was actually topological index of a molecule, which is defined as the sum of the lengths of the surface paths between all pair of vertices, which also represents the non-hydrogen atoms in molecules. So actually, Wiener index was developed for chemical graph theory, but in 2020, see, after many years, Binu et al., they introduced the Wiener index for fuzzy graph. So people are actually they are developing all the results. They are trying to develop all the results which are there in Krebs graph in fuzzy graph. So in that direction, Binu et al. First introduced the Wiener index of a fuzzy graph, and they applied all the results to a real life application also. You can see this reference who are interested. So this is the definition of Wiener index in a fuzzy graph. I'm not going into the details, which time is very few. So Binu et al. They developed the Wiener index of fuzzy graph. That was the first result in fuzzy graph in topological index. And then in 2020, there is another researcher, Kalathian et al. They introduced the first Jacob index and second Jacob index of fuzzy graph. So actually, first Jacob index and second Jacob index, these are there in the Krebs graph, but in fuzzy graph, this researcher Kalathian et al. They introduced in fuzzy graph in 2020. So these are the definition in fuzzy graph. Actually, they modified all the results in graph theory into Krebs graph theory into fuzzy graph theory. And then actually there is some errors in this definition. And later on, one of the scholar or set scholar, Islam et al., they actually further studied on this indices and they modified this definition also. And they introduced the modified version of the first Jacob index. So you can see actually there is a difference in the definition of the modified Jacob index and the original introduced Jacob index. At the same time, actually, they also contributed many indices like in hyperconnectivity index and second Jacob index, hyperconnectivity index, and hyperjacob index. So they generalize many concepts in fuzzy graph theory, and they actually worked not only on the theoretical background, they also applied some um, application also. In 2021, there is another researcher, Alardi et al. They introduced the first interjagraph index, and it is used in chemical graph theory. Most of these indices actually they are helpful in chemical graph theory, and so this index was there in 2021 in Krebs graph theory, and we, myself and my one scholar, in 2023 we have actually verified this notion in fuzzy graph and introduced first interjagraph index and also introduced the second interjagraph index of fuzzy graph. So, and then also we have we are still working in these topics because there are so much, as you know, that there is so much topic to be discovered actually in fuzzy graph theory. So, so you see, again in 2023, this is recently developed, we can say, one more index that is neighborhood inverse symmetry index. Das and Monroe, they introduced this index in for molecular graphs. And this index is explored to have predictive performance and isomer discrimination ability, outperforming other well-known and widely used molecular descriptor. So this index is also very much helpful in molecular graphs. And again, in the same year, we have also introduced this index in fuzzy graph, and we have derived some results and applied it to model some real-life application. So in 2023, we have developed these two indexes, and still we are working, and some other work in this field. They are the Goodwin index and universal mean degree index, and so on. So who are working in fuzzy graph theory, I can say that there are so many indexes still to be explored. One can uh, one can see these papers or other papers also, and can start working. So so this is one of the emerging topics people are currently working. Not only we, actually, these results are developed just few years back, and currently you can see that there are many other researchers. They are generalizing this concept into other graphs like bipolar polygraph or intensity polygraph, as told. But currently we are working in the classical polygraph theory, because these are not uh, all these indexes. They are not fully explored in polygraph. So there is a huge scope of work in this topic. And currently, we are also working, and some other researchers from abroad also they are working. And one of the one of the speaker, like Matthew, he is also working in this topic. Also, I have seen some that winner index they actually first defined, and uh, they also work on this topic. He will also speak uh, today also. So another area of research is the fuzzy shortest path and longest path problem. Actually, uh, this is also an important research topic in fuzzy graph theory, because most real network operate under imprecise vague or human estimated parameters. So fuzzy shortest and longest path problem are highly beneficial. Okay, so because fuzzy model, they bridges the gap between only simplistic deterministic approaches and fully stochastic models, and that requires unavailable probability data, delivering practical, robust, and human intuitive solutions in transportation, project management, and so on. So in this direction also, there are so many works, as you can see. Actually, in this direction, the basic results are there in Bhutani and Rosenthal paper, because you need to know the strong words of fuzzy graphs. If you want to work in these topics, then you need to know the basic details which are available in this paper. In 2003, actually, they defined the strong words. Therefore, in the same direction, Matthew and Spiegel, they also studied also different types of works. Actually, Matthew and Sunita, they have worked on these topics mainly. I have checked in the literature. They have a great contribution towards these results. Actually, they have studied node connectivity and arc connectivity of the fuzzy graph. They also have characterized the partial blocks and weighted graphs. And the last one, the strongest long cycles and theta fuzzy graphs. This is actually very popular paper. Actually, it was published in IEEE also, and you may not be know that the paper in IEEE, they are very actually high quality papers. So if you want to work in these topics, then you can check these papers also. So they are working, still they are working in this direction. And recently, uh, another researcher from their community also, that Gayatri et al., they extend the connectivity concept of directed fuzzy incidence graph, and they have introduced the concept of legal fuzzy incidence blocks, legal flow reduction sets, and directed fuzzy incidence graph versions of Menger's theorem. and finally they applied these results to water distribution networks. So this topic I already told that they are actually engaged in working this type of works, and there are many more works related to this topic you can see in these references. So I have already discussed two topics, two emerging topics that currently researchers are working, and in recent year, in 2025, another researcher economists, they defined fuzzy graph hyperoperations and path-based algebraic structures. This is a new topic, and they actually studied about the fuzzy graph hyperoperation. And you see, sir already told in his presentation that there are two types of work. Namely, you can work on algebraic graph theory or algorithm. So Liao et al. They actually studied the algebraic approach for finding fuzzy constants or dispersion in fuzzy graph theory. So these researchers they are working on finding the fuzzy solid spot problem. Okay. The next topic that I am going to say actually not so much work has been done in this topic. I can hardly find 3 to 4 papers in this topic, and myself and one of my scholars have started working on this topic. Actually, this is the algorithms and the topology. Uh, Actually, with the mathematician, we try to define everything what is there in this graph. Uh, so people try to define topology from a given file graphs. So there are so many approaches. We know topology, right? Maybe the students of first semester, don't know what is topology, but topology is there in our second semester. So those who know that is good. But here the researchers are what trying to do. So given a file graphs, they're trying to develop a topology to study the topological property of the graph actually. So in this direction, the mathematician Coulomb, he first defined the topology for integers that we learned from our mathematics course in MSc mathematics course. And we see that the topology is also generalized in fuzzy version by Chang et al. In 1968. And thereafter, these concepts, these are generalized by Seja. He actually weakened the condition of topological space and introduced the idea of generalized topological space. And then 2010, Madizwan, he studied the relation between the directed graphs and finite topologies, for which he associated a topology with the vertex set of each directed graph. So these works are there in the Krebs graph actually. In Krebs graph, you can see so many works in this direction, but in fuzzy graph, this is very new topic. So these were the research, Abdu and Kidman. In 2018, they introduced a new approach to the construction of topology on directed graphs. So these results are only on the Krebs graph. Okay. So, so then in 2021, uh, Jomam et al. They investigated the graphic topology. So graphic topology is a graph and topology that is known as the graphic topology. But you see, the basic topology that was introduced in 1959, and later on, you see, in 2018, Abdu and Klickman they studied topology on directed graphs. Okay, and after so many years, after so many years, Athel et al., most probably in 2021, they first introduced a new kind of fuzzy topological structures in terms of fuzzy graphs called the fuzzy topological graphs. So this is the actually please complete with me. Okay. So this is the first work in the fuzzy topological graphs that I can at least found in the literature. So after a long duration, the Arthur et al., this is the first paper. Three Gulab and Nikum, they also introduced various type of fuzzy topological spaces on simple connected fuzzy graphs by using the adjacency relation. And this is actually our work. We have just completed this work. We have defined maximal path as generalized topological space on a directed fuzzy graph. Since the time is very short, so I'm not going into the details. So this is actually our first work, and we are aiming to work more work in these topics because it's still open. Anybody else also can work in this topic. And there are finally this is one more topic, generalization of fuzzy graph. As I already told, the interpolated fuzzy graph. Actually, those who are working, they can also work on interpolated fuzzy graph. Actually, this topic is also not much explored. I have checked the literature. Still, so many work can be done here also. And then I think there it is bipolar fuzzy graph. So Akram it will we first defined the bipolar fuzzy graph. I have also worked some paper on bipolar fuzzy graph, uh, and then the impolar fuzzy graph. Actually, that was my thesis on impolar fuzzy graph. I have actually first J. give the definition of impolar fuzzy graph, but later on we have generalized and introduced generalized impolar fuzzy graph and published many properties. And also in literature you can see the new graphs like hesitancy fuzzy graph, Pythagorean fuzzy graphs, Newton fuzzy graphs, and I have limitedly mentioned some graphs. Actually, you can found so many graphs. But my suggestion is to the new researcher is that you try to work first in classical graph, and if you think that if you are not comfortable in that part, then you can generalize. Otherwise, you try to work on the classical calligraph that part, which part is not explored at all. And you see, there is another researcher like Anusri and Sir. They have introduced a new topic like fuzzy covering problem of polygraphs, vertex covering problem, and then click covering of polygraphs. So these are very nice papers you can check, and they are published in good journals also. So this is also a very good topic of research, and later on many more people have worked. Okay, so this is my final and important slide. The future research direction is paragraph theory. So one can define new topological indices in paragraph which are not yet done, and one can define dynamic and time-varying paragraphs, machine learning with fuzzy graphs in network resilience, multi-layer and multi-criteria fuzzy graph models, and fuzzy graph based optimization, or one can work with algorithmic and computational direction also. So, so there are many areas to be explored, and still it's a new topic, I can say, because you see, although there are so many papers published, but in classical fuzzy graph theory, there are still so many open research direction you can work with. So these are the actually references that I have used. And finally, my time slide is coming, but it is coming very slowly. Okay, so I think I have finished my previous meeting time. Thank you for listening to me. Thank you. If you have any question, I'm happy to answer them. If you have any questions, you can ask. Any question? So, my suggestion is that if you have one slide, where the topological index is applicable to analysis the physiochemical properties of some physiochemical properties of some hydrocarbons. Yes, yes. Okay. If I write the equation like you said, yes, sir. Good size. And actually, since the time was very less, so yes, this preparation could be much improved. Later on, I will try. Okay, anyway. So, I have one question. Yes. What is the physical meaning or indifferentiation of two indexes, like a Zagreb index of 2 grams? So, if 1 gram has higher Zagreb index and the other is lower, what is the physical meaning of it? Actually, these indexes actually they mean some physical chemical properties like boiling point. Okay, so from this value you can say the boiling point like this also. Chemical property. Yes, physical chemical properties. So that one is not connected with, not necessarily connected with the body. So every political index has different application. Yes, yes, yes. Every index has a specific application. There is some specific application, then that particular index has gain, it has no. Yes, yes. So for different definition, it should be different values. We cannot compare the different values from different. Hmm. Because compare the values. Again, these indices are coming from chemical graph theory. They have a strong background to introduce. But in polygraph theory, we are trying to define a polygraph. But I don't see the polygraph theory is actually applicable in that sense. Actually, we are modeling some real life polygraph theory, topological indices for polygraph theory. So, they have applied this concept in a system migration. So real life problem there we are applying actually. Thank you, Dr. Ghorai, for the nice interactive session. So thank you, our speaker, Dr. Ghorai, for his nice deliberation about topological polygraph theory. Topological polygraph theory. Thank you so much. Topological polygraph theory. And thank you also, our chairperson, Dr. Shobhan Saunto. Our next session before the Lord break. That will be delivered by Professor Joshi M. Mary Hindal,
Yes.
University of Technology. So this lecture will be in online session. And this session will be chaired by our head and convener, Professor Madhumohan Pal. I request our sir to take the responsibility to continue this session. Please, sir.
Hello. Hello. Should
Hello.
I? Hey. Okay. Yeah. Okay. You hear me well, right? Yes. You hear me, right? Yes. Okay.
Sir,
Okay.
are you okay, sir?
Yes, I'm here. Whenever you want to start, I need to share my PowerPoint, or do you? Let me see. I have my PowerPoint here. Can I? Can you allow me to share?
Sir, am I audible?
Yes. Okay. I'm sharing my PowerPoint. Can you see my PowerPoint?
Yes, sir. Yes, sir. Please wait 1 minute. I am introducing you before the your participants. Okay.